All right, we're going to get started now talking about section 10.2, which is angles and arcs. It's a continuation off of what we did the other day. So a central angle is an angle with its vertex at the center of the circle. So this would be an example of a central angle. Its center is at the center of a circle. The sum of central angle, there is a theorem here. The sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. So all of these angles, so this is a central angle, this is a central angle, and so is that one. So all three of those should add to 360. RU is a diameter in this picture. Find the measures of each central angle. So if RU is a diameter, it means it cuts the picture in half. So I just want to point that out. It cuts the circle in half. Half of 360, okay, 360 divided by 2, that would be 180. So that means that this is 180 here. Okay, that's very important. And they're also telling you here that this is a right angle, so that makes this 45. Okay, so just dissecting this little picture here, I'm going to zoom into it. Okay, so they told you right here, this is a right angle. Half of 90 is 45, so that makes this other piece 45. Okay, this marks the fact that this side's 180 and this side's 180. So I know that I have 2 out of the 3 pieces that make 180, so I can easily find if I add these together. So I could do 180 minus, I have a 45 here and a 60. That makes this piece here 75. Okay. I also have here that this is 45, and together with this, it should add to 180. So I do 180 minus 45 to get that this little section here is 135. Okay. So that's just a quick way to dissect this. Remember that a diameter makes half the circle, which is 180. Okay, diameter makes half the circles, which is 180. All right, so now zooming out here, let's just answer a few of these quick questions. What is SCT? SCT, that's the 75 that we found. SCU is 75 and 60. So I'm going to add those together. 75 and 60 gives me 5. Here that gives me 13. So 135. SCQ here is that 90. Okay. And QCT, that's a big one. QCT, that is going to be QCT. I have 4590 plus the 75. 90 plus 75 gives me 165. Okay. All right. Now we're going to go to our next page here. Where we talk about arcs. An arc is an unbroken part of a circle. The symbol for an arc looks like this. It's like a little half circle. Types of arcs, we have a major arc and a minor arc and a semicircle. A semicircle we've kind of already talked about. It's the 180. It's half a circle. Okay. Here for the major arc, we have, it always is labeled with 3 letters. Okay. A minor arc is always labeled with 2 letters. So for example, here in this picture, you'll notice it's the same picture in both of these. A minor arc would be this small one, HI, and I'd put that arc symbol above it. you don't have to include this center, okay? And then, so basically we're only including the letters that are on the outside of the circle. Don't include that center point ever, okay? Then also for the arc, this would be our major arc. So from H to J to I. So H, J, I, 3 letters would be my major arc. I could also switch it around and say IJH. Same thing here. I could say IH. I can switch it around. The definition of arc measure: the measure of a minor arc is the measure of its central angle. So we just talked about central angles. Whatever that measure is should be the same as the arc. The measure of a major arc is 360 minus the central angle. The measure of a semicircle is 180. So first off, looking at this picture, we are going to dissect it and just write down, is it a minor arc? Is it a major arc? Is it a semicircle? So first, BA, it's 2 letters. It's not a semicircle. So this is a minor arc. CD, once again, 2 letters, not a semicircle. That's a minor arc. BCD, okay, that is a semicircle. Okay, if that's a diameter, that's half the circle. AD, once again, it is not a semicircle. It's 2 letters, so it's a minor arc. 3 letters here, A, C, B. Now, some of you might have wondered, do I go A, B, C? No, if C is the next letter, you have to go to C. So A, C, B, that is definitely a major arc. That's a big one. And BC is a minor arc. So now they're giving us some pieces of information here. BD is the diameter and AC is the diameter. We already knew that. Now let's find all of these measures, knowing that this is 44. So BOA is 44. That means this arc is also 44. Okay. So AB is 44 degrees. That's something we know right away. Now we also know that this is a diameter, meaning this would be 180. So we can do 180 minus 44 to get that this is 136. These are vertical angles right here. So I can say this is also 44. This is also 136 because of vertical angles. Be careful using your vertical angles when we do this, just because you have to always make sure that they have to be vertical. This line goes directly into that one. This one goes directly into that one. Sometimes it can be a little tricky to see, kind of like in the first problem we did today. Just show you a quick example. Some of you may have mistaken TU and RQ, those as vertical angles. They're not, because this line goes into that one. This line, if it kept going, would go bigger. Okay, so that's just an important thing to note when looking at this. The minor arc BC would then be 136. Okay. The minor arc CD would be 44. The major arc A, C, B, that's a big one. So the whole circle is 360, right? ACB is the whole circle except for this 44. So I'm just going to do 360 minus 44 to get my 316. Okay, you could have just added 136, 44, and 136. That was just a quicker way I could see it.